Okay, now we will continue on the second step on how to determine the order of the reaction. Okay, we're done with initial rate method. Now we move on to integration or graphical method. Okay, on this one we have to go with the graph. Okay, let's say we start with zero orders first. Okay, this is the graph of zero orders. Okay, right, for zero order, okay, we have x. This is x-axis. This is the x-axis, which is belong to A, concentration of T, and then this is the y-axis, which is our T. Alright, and then this is the slope. Slope is negative minus K, and then this is the intercept A, concentration of at A naught. So you don't have to worry how come this figure is like this. So you have to take it, just take it as that. Alright, so now when we compare to mathematical formula, y is equal to mx plus c. Alright, so you have to take one by one. What is our y? At the axis of y, okay, that is concentration of A power of T. Then that's equal to m. Okay, m, our slope is minus, negative slope, so you have to put minus K. Okay, and then T is represent our x. Oh, sorry, this is y. Okay, this is x. Okay, T represent our x, okay, plus C, the intercept is A, concentration of 0. Okay, so now it's clear how y is equal to mx plus c is related to this graph. Okay, so you have to memorize this formula, right? This formula, right? AT is concentration at a particular time, while A naught is the initial concentration. Okay, if we compare the rate versus the A, concentration of A, we found out rate is equal to K, where K is a constant. Okay, why K is constant? Because Ka, if we put A power of 0 here, that will bring, because this is zero order, so that will bring that rate is equal to K only. So K is constant. Right, so that's why this graph is coming in. Right, so this is how we determine the order of the reaction based on graphical or integration method. Okay, now we move to first order. Again, there is a graph. Okay, this is a graph of first order. What different here? We have ln on y, we have ln on the intercept. Okay, so this is still the x-axis, this is y-axis, this is m, the slope. Okay, it's still negative, so minus k. Alright, and then this is the intercept. So while we compare with y is equal to mx plus c, you're going to get this one. Ln AT is equal to minus KT plus ln A naught. This is the one that you have to memorize for first order. Alright, so while we compare, okay, still the same. Concentration is still the same. While we compare the rate and the concentration of A now, if you put rate is equal to Ka power of 1, this is actually K is the proportional to the rate and concentration. Alright, so that's why you're going to get this kind of graph. So you have to remember both graph, okay, graph ln and also graph rate. Okay, we go with the third order, second order. Second order, the graph now involve 1 over A for y, x is remain, okay, and then 1 over A naught for the intercept. But what different here is m, now the slope is positive. Okay, it has positive slope. Right, so while we compare with y is equal to mx plus c, you're going to have this one. Y just replace with 1 over A is equal to K positive now, so you don't have to put a positive sign, just put KT. T is represent the x plus C, the intercept is 1 over A naught. Okay, right. If we compare with rate and Ka power of 2, this is for second order Ka power of 2, you find out your K still slope positive. Okay, right. So that is second method, integration or graphical graph, and then the third one is half-life. Half-life is T half. Okay, everything, all the living thing, it has its own half-life. For example, we ourselves have our own half-life. For example, let's say our say that our life would be reached to the max of 50 years old, so our half-life is basically 25. Okay, we already reached the half-life, for example. Alright, so this half-life meaning half everything that had been halved from the concentration. In this case, we refer to concentration of the reactant to decrease half from its initial concentration. So we may say that T half is equal to T when concentration of A is equal to A naught, initial concentration over 2 divided by 2, okay, being cut to half, right? So next, okay, so you have to memorize the formula for zero order. T half is equal to A naught over 2K. For first order, now is involve ln, because our graphical method just now also involves ln. T half is equal to ln 2. Ln 2 is equal to 0.693 over K. While first order, we involve the proportional division 1 over K A naught. Okay, so there's no other way except to memorize them. Right, so if you look at this one, first thing first, this is graphically how we determine the half-life from graphically. If you have zero order, the slope is, if you have zero order, the slope is 1. Sorry, if you have, I couldn't go back. Okay, if you have second order, the slope is remain. If you have, sorry, first order, the slope is remain. If you have second order, the slope is negative. Alright, so what most important here, okay, this is all the summary of the order 0, 1 and 2, and how to write the rate law. Ka power of 0, so it's equal to just K, and then rate is equal to Ka, and also rate is equal to Ka2. Units, okay, this is based on if you have a concentration, K, yes, rate, okay, molar per second, this is only per second, this is per molar per second. Okay. For integration, this is based on the graph just now, what we see from the graphical or integration method. So you have to memorize this formula. Zero order, this is the formula. First order, this is the formula, and also for second order, this is the formula. Easy way to remember when it's involved first order is involved ln. Ln concentration A and ln naught minus KT, while it's involved second order is involved 1 over concentration. Okay, and then that's note at the back. Okay, right, and then same goes to the half-life of T half A naught over 2K. For first order ln 2, which is equal to 0.693 just now over K, and then T half for second order is equal to 1 over Ka naught. Right? So in order to understand more, you must try this calculation. For example, a reaction is given from 2A to produce B. Being told that this is first order, so you must know what formula to use. Okay, the rate constant is given, K value is given here. How long means it's asking T will it takes for A to decrease from 0.88 molar, this is concentration, to 0.14. So this is initial concentration, this is the final concentration. So which formula to use? This one. Okay, so we might say that initial formula as A naught 0.08, A final is 0.14 molar. Okay, so we can use for first order, this is the formula. Ln is equal to ln A is equal to ln A naught minus KT. We want to find the T, right? Okay, so now you rearrange the equation, make KT as a topic is equal to ln A naught minus ln A. Now make it T as a topic by divide all of them with K, right? So ln minus ln is actually brings to the division. Okay, ln A at initial over concentration of A, that will divide by K, right? So when you bring in all the concentration just now inside the formula, the ln 0.88 molar over ln 1.4 molar, so that divided by K. K, you know the value is being given, right? So in the end you can get T is equal to 66 seconds. Okay, right, or 1 minute 6 seconds. Okay, also can be put, but 66 seconds is much more nicer. Okay, right, so you may try this exercise. So we have the answer here. Please compare, please do properly so that you can get the right answer over there. Okay, there are a few exercises here. Please do try.